Excellent, you're here in our 7th lecture on our solutions unit. This is the last lecture of the unit. Okay, we're going to cover freezing point and boiling point manipulation. So how adding a solute to water will change the freezing point and the boiling point of the water. Okay, and it's how it's related to concentration. Okay, so this is a very common phenomenon that nobody ever thinks about. Put salt on the sidewalks in the winter to prevent the ice from freezing on the sidewalks. Many people think the salt literally heats up the ice, but it doesn't. It does this. It's called the colligative properties of water. So what happens when you add a solute to water? First thing happens. The water's boiling point, which is normally 100 degrees Celsius, rises. So the boiling point increases to like 101, 102, 103 degrees Celsius, depending on how much solute you add. More solute, higher boiling point. Okay, the saltier the water, the higher temperature it will boil at. The other thing that happens is that the freezing point, 0 degrees Celsius, drops. So what that means is by adding salt to the water or salt to ice, the molecules of water won't freeze at 0 degrees Celsius, but they'll freeze at like -1, -2, -5, -10 degrees Celsius. So it's not that the solute heats up the water, making the ice not freeze. It's actually that the molecules cannot freeze because there's solute in the way of the molecules sticking together into the solid phase. Freezing point drops, boiling point goes up. Okay. The higher the concentration of solution, so the more salt, the more sugar, the more solute you add to the water, the greater the change in these boiling point and freezing points. So if I add a ton of salt to my water, it's going to boil at a much higher temperature than 100 degrees and freeze at a much lower temperature than 0 degrees. Okay. So let's see what we got. Oh, I got to go to the board and write this out. So covalent compounds, when they dissolve, they split into molecules. They split into molecules. That's important because those molecules slip between the water molecules and prevent them from freezing. But when ionic compounds dissolve, they both split apart and dissociate into ions. Dissociate into multiple ions. So this has a greater MP-BP effect than the covalent compound. So fact to remember, ionic compounds affect the melting point and boiling point of water much greater than covalent compounds do because they split into multiple ions. The multiple ions make it so that there's more stuff in between the water molecules and the water molecules can't freeze or boil quite as easily. So when you add a covalent compound to water, the boiling point rises slightly. But when you add an ionic compound to water, the boiling point rises significantly. Okay? The freezing point, remember, the boiling point rises and at the same time the freezing point drops. So the freezing point when you add a covalent molecule to water, it lowers slightly. But an ionic compound, when you add it to water, the freezing point lowers significantly. Again, because of multiple ions at play. Multiple ions at play. Okay? The more ions an ionic compound can release when it comes in contact with water, the greater the effect on the freezing point and boiling points changes. Okay? So calcium chloride releases 3 ions versus sodium chloride, which releases 2 ions. Calcium chloride would have a greater effect on the freezing point and boiling point of water because it has multiple ions, more ions than sodium chloride would. Okay? Let's see what we've got here. I got to erase these things here. Boom. There we go. Let's get our next click in there. So the effect is increased as the number of moles of compound are increased. So the higher the concentration, the greater the effect. The effect is multiplied by the number of ions in the ionic compound. Like I was saying, if the ionic compound like NaCl releases Na pluses and Cl minuses, but calcium chloride, that turns into a calcium ion and 2 moles of chloride ions. So there are actually 3 total moles that are released in that particular scenario versus sodium chloride, which is only 2. So the more ions, the more the effect. It's a multiplier. Okay. Lithium bromide is the other example. 2 ions in solution versus magnesium chloride, another example, which would release 3 ions in solution. So the magnesium chloride would have a greater effect on freezing points and boiling points. Let's see what else we got here. The effects are increased as the number of moles of covalent compound are increased. Obviously, this is the covalent side of things, but the effect stops here as covalent compounds do not dissociate into ions. When you put like phosphorus trichloride, it's only going to produce 1 molecule in solution. The phosphorus and the chloride cannot split apart because they're covalently bonded, so it's stuck as 1 molecule, so its effect is diminished. So when KCl is added to water, will it dissolve? Yes, it is soluble. How many ions will it dissociate into? I think it's 2, K plus and Cl minus. Would this solution raise the boiling point of water? Yes, it would. Would the solution decrease the freezing point of water? Yes, it would. CH3OH, that is methanol. It's added to water. Will it dissolve? Yes, it will, because they're both water and methanol polar. See, it says this is a polar molecule. It will dissolve in the water. How many ions will it dissociate into? None. It's covalent. So it is not going to have an ionic effect. Would the solution raise the boiling point of water? Yeah, slightly, but not very significantly. Would the solution decrease the freezing point of the water? Yes, slightly. Compared to an ionic compound, would this compound have a greater or lesser effect on the melting point and boiling point? It would have a lesser, because it does not separate into multiple ions, like an ionic compound does. Ooh, does. Boom. Sorry for my chicken scratch handwriting. If 1 mole of magnesium chloride, 1 mole of lithium chloride, and 1 mole of magnesium carbonate, and 1 mole of NO2 are all added to separate liter volumes of water, which would have the lowest freezing point, and why? So the solubility rules. Magnesium chloride, it does dissolve. That makes magnesium plus 2 and 2 chloride minus 1s. Lithium chloride, that makes just 1 lithium plus 1 and a chloride minus 1. Magnesium carbonate does not dissolve. So that is going to have no effect. It doesn't even dissolve in water, so it couldn't possibly have an effect. And NO2, well, that just makes NO2. It cannot dissociate because it is covalent. So which one would have the lowest freezing point? I think this would have the lowest freezing point. And then the magnesium carbonate, because it does not dissolve, would have the highest freezing point. And we're almost done here. You got to check out question 4 because our video is about to end. I think you can do that one on your own. Ooh, 5 and 6, the same kind of story. We got to just work through the lesson, work out your practice, and that's the end of the unit. Hopefully, you're ready and you can do our lab